Hi all, and welcome to your second lesson for the week. We're going to talk about describing sets using Venn diagrams. So again, get your notes ready. Might be one where if you have a printer, it might just be easier to print them off because you're going to be going through a lot of drawings like this, and if you don't want to recreate that for all 6 parts, that might be worth getting the printer out. Otherwise, get yourself ready for notes and let's get started. So when we talk about Venn diagrams, one thing that's really helpful to think about is this box here, which you maybe don't see on all Venn diagrams, is going to be what we're going to call the universal set. So this large box is the universal set. And then we can think about the 2 circles and sides as the set A and the set B. Now we can use these sets to illustrate different points. So for example, I'm just going to work my way through these. We're going to start with A union B. Now for A union B, that's everything in A, which would be this set, and then also everything in B. And I do a little bit nicer job in the guided notes that are attached coloring these in, but basically the union of these 2 sets is both circles completely colored in like so. So we're not even worried about the universal set right now. So the intersection, as you could probably guess from the way it's written, is where these 2 intersect. So it's where it's in A and B right here. So it's the place in the Venn diagram where the 2 sets overlap. Now, next, we have A minus B, which would be everything in A, so this circle of A, and then minus anything that's in B. So we can take our eraser and say, okay, well, if you're also in B, we want A minus B. So that would just be this crescent shape in A. So you'll notice that the first 3 we went through, just like what we talked about last week, these don't use the universal set at all. However, D, E, and F are complements, so we are going to end up using the universal set. So let's start with the complement of A. So the complement of A would be anything in the box, so anything in this universal set that's not in A. So if you want to continue to think about it as a subtraction problem, there I've lightly shaded the universal set, and then again I'll take my eraser, and anything that's in A is being taken out. And what's left behind is the complement of A. So it's everything outside of that circle. Now here, sometimes it's helpful to do a couple different types of coloring and erasing with your Venn diagrams. So the way I like to think about something like A union B complement is I'm going to think about that first drawing that we had here of the union, which I will shade in green. So that was, if you remember, that was just everything in here. And then therefore its complement would be everything that we have not shaded in here. So that would be all the box that is not inside either of the circles, would be the complement of the union of A and B. Now you'll notice that the next one is the complement of A intersect the complement of B. Now, if you were being sneaky, you would remember that we already proved that these 2 are equal in our last lesson. Now, another way that you can convince yourself, now Venn diagrams do not count as a proof. So just because 2 Venn diagrams end up looking like each other doesn't necessarily mean that they are exactly the same. However, it's a nice way to offer a very clear disproof since it's a counterexample. So for complement A intersect complement B, I'm going to start by illustrating the complement of A in green, which we've already done in part D, and then go back in with the complement of B. I'm going to use red, so that would be everything not in the B circle. So shading in this space of everything that is outside of the B circle. Now the intersection is the overlap where both shadings are happening. So you'll notice that's here where we have red and green around the outside here, but the inside of A we only have red. and the inside of B we only have green, so that wouldn't be in the intersection, that would only be in the union. And we have this set, which again you'll notice is completely identical to what we had for E. Now, Venn diagrams absolutely work with these two circles and the universal set. We can also throw in more sets. So, for example, here we could say, well, we've got an A, a B, and a C. And the basic similar rules will apply. So if I'm looking at G here, this says the intersection of A and B and C. So what that means is everything that is in A and B and C. So it has to be in all three. And the nice thing about Venn diagrams is it kind of works the way we think it should, because if this is A, this is B, and then this is C, the only place where they're all intersecting is this space in here, which is the correct Venn diagram for part G. Now, sometimes as we increase our number of sets, it becomes a little bit trickier. So for example, H, it asks for the intersection with the union of these two sets and C. So the union of those two, which is going to be similar to what we looked at earlier when the two sets, is everything in A and everything in B. So it's both circles filled in. We're asking where the intersection is that with C. Well, if C is this part here in this circle, the intersection is where everything is colored in both colors. So we have this sort of leaf petal shape, as well as the other one here. And then the intersection would be shaded in this region altogether. So I know that these diagrams aren't super neat. If you want to see neater pictures, please refer to the PDF that's attached. If you have any questions, you can leave them in the comments or make a meeting, and I'll talk to you later. Bye.